Hello, I'm here to show part one for the Xfoil project. This part one right here. As you can see, we're going over these three different airfoils, and we're just going to look at some different data points for the Reynolds number of 1 million and see how each airfoil kind of reacts to it. And we'll make some graphs and get some tables of the information. But to showcase how you go through each one, I'll start with NACA 15. Click pane. I'm kind of just doing how the tutorial shows to kind of set up each airfoil. Going along with 250 panel nodes. T is 1. As you can see, it's changed the diagram for our airfoil, kind of giving it more nodes. Next, we'll go to Opera. We're doing viscous at 1 million for our Reynolds number, so we'll change that. Change our Reynolds number to 1 million. We'll want to change our iterations to 100 because 10 usually is not enough for convergence. Next, it's asking us to look at alpha varying from -5 degrees to 15 degrees with an increment of 1 degree between each. So I'm just going to do the ASEC thing in the program. -5, 15, 1 is just taking us from alpha equals -5 to alpha is 15 with increments of 1. Click enter. As you can see, it's given us our information here, but obviously that doesn't do us good if we're trying to put it in Excel. So to do that, type in PACC, and I'll just make a file name, call it, I'll just name it after the airfoil like that. Don't need a dump file. And then I will do the same thing again. Well, I'll initialize it first. And then I'll do the same thing again. And let me pull it up in the folder. Where that folder at? Oh, here it is. We'll click on it, we'll do it in Notepad. And as you can see here, it'll give us the data points for each of the alphas, and then after this, I can put it into Excel. Oh, I already have it open for the other ones, but I'll just go to Open, Browse. I'll go up to Xfoil, click on NACA, open it. Yes, just next, next. Finish, and as you can see here, it's just giving it to us in Excel like this, and I'll go through the other two and kind of do the same thing. So I'll minimize these. Let me close Xfoil so I can do a new one. Okay, so we'll go NACA 2415. And just kind of doing the exact same thing I did for the last airfoil I just looked at. This time with NACA 2415. So we'll do 250 nodes, T is 1. It's the same deal, it's just Reynolds number is 1 million. So 1, 2, 3, 1, 2, 3. Go ahead and save it to a file. 2415. Then we'll do our varying alphas from -5 to 15 with increments of 1. Click enter. Runs pretty smoothly. And let's see. Here we have it right here. Open it up in Notepad. As you can see, same deal. just going through each of the data points, giving them all to us. Exit out of that. Minus that. And then same thing in Excel. If I want to open them, browse, just click on it. Open, yes. Next, finish. And here we have it right here. Kind of the same thing that I did with the last airfoil. And then last, we have the Clark W airfoil, which I had to find online from the UIUC airfoil database, which UC airfoil database. I'm not going to re-download it, but just kind of showing that, I got it exactly from right here. And after I got it, I had to rearrange the numbers because Xfoil really likes it I say really likes it, it only likes it if you have it going from your trailing edge to your leading edge back to your trailing edge. So when I downloaded it, there was way less points than this. There was only 34 points, but it started not from the trailing edge, so I had to rearrange the top points. But whenever I put it into Xfoil and I changed the node number to 250, it kind of changed all my points. Well, I'd say changed it all, it just added a ton of points. But when I load it up, you can see really that it's the same airfoil. So, and I get the same graphs and stuff that I should be getting. So I'll load it up in Xfoil. Let me close this other one. So I'll click load Clark W. I just have it as a text file. Have it loaded. PAR. As you can see here, I have the Clark W airfoil right here. 250 nodes. Let me change T real quick. Oh, change the nodes. Okay, let me. There we go. Okay, just doing the exact same thing we've been doing. Change it to viscous, 1 million. We will make a file for it. Just gonna do new Clark W because I already have a Clark W file that I've saved. Okay, then we have our sequence, -5, 15, 1. Oh, let me get the iterations first before I do that. Okay. Just a little bit, but here we have it. And same deal. If we look, our Xfoil, got your new Clark W right here. Open it up in Notepad. And we have all of our alphas, all the information attached with them right here. Same deal, just go to open, browse, new Clark W, next, finish. And here we have it. But I already have my Excel spreadsheet that I made for part 1, like already set up. So I'm just going to switch it to that. Kind of have my numbers all sectioned off. Kind of nice. Let's see, looking through each of them. It's the same thing. It's just I did it previously. You have your Naka 15, Naka 240, or 2415, and your Clark W all here. Part of the question was getting the lift slopes for these airfoils. So all I did was I kind of just manually found them by kind of doing like rise over run. I just had my my lifts from alpha equals 0 to alpha equals 4 degrees, and I just subtracted the lift at 4 degrees minus the one at 0, and I just subtracted 4 by 0, And I did that for each of these, and it gave me these lift curve slopes here at the bottom. So that's how I did those. Minimum drag. Well, actually, I have my Word document I've been putting this in. So if we go up to part 1, here you can see I just went through my Excel and got, you know, my minimum drag coefficients. I got my my maximum aerodynamic performances, all that, and I put them here along with my lift curve slope. So that's about it. I also, you know, I have the graphs. I just, you know, just kind of made a graph how you do in Excel. I don't really know how to explain it other than that. I just made a scatter plot and select data. Just do add. Well, for example, if I'm doing Clark W, my X's, of course, are going to be my alphas, and my Y's are going to be my CLs. If I were to do this for the coefficient of lift versus alpha, click that, click OK. Okay. As you can see, it doesn't have the same, you know, the legend or the chart titles or what have you for the other ones, but this is basically just how I did it for this. And then, you know, I'd add the NACA 2415, NACA 15 to this, and then I'd make a graph for aerodynamic performance and coefficient of drag. So that should be about it for part 1. And of course, I have my table for everything right here. But yep, that's it for part 1. Let's see, how do I get out of here? Okay. And then on to the next ones.